This time we're going to talk about exponential functions. And the first thing I want to do is actually talk about the definition of an exponential function. And here it is. We see that an exponential function is one of the form f of x equals c times a to the x power, where a is a positive real number and it's not equal to 1. If it were equal to 1, then all of your answers would be the same. Raising 1 to any power is going to give you the same number. C is a real number, and C is not 0. If it's 0, then all our answers again would be 0. A is called the growth factor. It's called the base also. And C is the initial value. Some examples of the exponential function are as follows: y equals 2 to the x, y equals 5 times 3 to the x power, and y equals 4 times 1/5 to the x power. Notice the base, in this case, is the fraction 1/5. The punchline? The exponential function uses x in the exponent. That's the key. Notice in every one of these, x is located in the exponent. Now, to evaluate an exponential function, we can evaluate them by hand, or sometimes we have to use a graphing calculator to do it, or a calculator anyway. But we will evaluate them by hand if at all possible. For instance, if f of x equals 2 to the x power, how do you find f of 5? Well, basically what you do is we're going to put 5 in the place of the exponent. So we would have 2 to the 5th power. That's what y is, and 2 to the 5th power is 32. So f of 5 would be 32. If x equals 5, y equals 32. How about f of negative 3? Well, in order to find the y value, we're going to put negative 3 in the position of x. Now, a negative exponent means reciprocal. So therefore, this is 1 over 2 to the positive 3 power, which is 1 over 2 to the 3rd is 8. One more example. F of 1/2. Well, in this case, as always, the 1/2 is going in the exponent's position. In this case, a fractional exponent refers to a root. The denominator is the root. So in this case, what we're really asking for here is the second root of 2, or the square root of 2. And we'll leave it like that. And lastly, f of 1.5. Now, in order to do this, we're going to put 1.5 in the position of the exponent. Now, in this case, we would need a graphing or a scientific calculator in order to work it out. And basically what you do is you use what I call the up key, the up caret key, or the y to the x key. And basically you'll input 2, press this button or this button, and then enter your 1.5. So you're raising 2 to the 1.5 power, and the answer you're going to get there is 2.82 something. I'll round it to 2.83. So the answer to that is approximately 2.83. Now, the next thing I'm going to talk about is the graph of an exponential function. And basically, the graphs are going to fall into one of two categories. And the categories are determined by the base, which is A. And there are two possibilities for A. Remember we said A, I'll go back to this, Remember we said a is a positive real number not equal to 1. Well, now if that's the case, a can either be greater than 1 or a can be between 0 and 1. Now if a is greater than 1, what you're going to be doing is raising a number greater than 1 to different powers to get your values. So the graph is going to look something like this. Whatever a is, that's going to be your y-intercept. And it's going to be an increasing function. So it's going to look basically like this if a is greater than 1. On the other hand, if a is between 0 and 1, then you basically have a fraction, as we did up in our example up there when we found, we have it graphed with a fraction. We use one in our example up there though. If the base is a number between 0 and 1, then basically as x gets bigger, you're raising a fraction to bigger and bigger powers, which means you're multiplying a fraction by itself more and more times, and the result of raising a fraction less than 1, multiplying it by itself more and more times, the answer gets smaller and smaller. So that's why this is a decreasing function. So the two possibilities: if a is greater than 1, it's going to be an increasing function with the y-intercept at a. If a is between 0 and 1, it's going to be a decreasing function with the y-intercept of a. Now the next thing we're going to talk about is solving exponential equations. And that's kind of what we're headed for here. Remember we said at the first of the semester that we're learning to solve different kinds of equations. And the latest that we're learning how to solve would be the exponential equation. So that's what we'll talk about. We'll touch on today. And I'll tell you the technique first, and then we'll do a few examples. The technique: you want to get both sides in terms of the same base, if it's not already, and then you set the powers equal to each other and solve. This is the technique we're going to use. Get both sides in terms of the same base, set the powers equal, whatever the exponents, the expressions are, set them equal to each other, and solve this little equation that you created. That will give you the answer for the problem. For an example, let's suppose we're asked to solve the exponential equation 3 to the negative x equals 81. Well, the base on this side is 3, and the base on this side is, well, 81. This is 81 to the first power. We want to write both sides in terms of the same base. We're kind of stuck here, but over here, 81 is a power of 3. As a matter of fact, 81 is 3 to the fourth power. So what I'm going to do is, I'm going to come over here and I'm going to write 3 to the negative x equals, and what I'm doing is replacing 81. 81 can be written as 3 to the fourth power. Now that I have both sides in terms of the same base, I'm going to set these two exponents equal to each other. So I'm going to write an equation based on these exponents. So what I'm going to do now is I'm going to write negative x equals 4. And to solve this for x, multiply both sides by negative 1. X equals negative 4. And that is the answer to this original equation. For my next example, we're going to solve 1/4 to the x power equals 64 squared. Now, in this case, I will avoid the fraction if I can. And this one is pretty easy. This one can be written as 4 to the negative 1 power. That way I have a whole number. So I'm going to write the left-hand side. Now notice what's happening. Here's what I'm going to do. I'm going to replace the 1/4. I'm going to replace it with 4 to the negative 1 power. Now on the right hand side, I still have this squared. I'm going to rewrite 64. Now remember, I have to have both sides in terms of the same base. So it is true that 64 can be written as a power of 4. As a matter of fact, 64 is 4 to the third power. So now I have 4 to the negative 1 to the x power equals 4 to the third to the second power. So what I'm going to do here is I'm going to multiply these exponents together so that I have an exponent to deal with on each side. So this is going to be 4 to the negative x equals 4 to the sixth power. Now I have my exponents, negative x equals 6, which means x equals negative 6. So I have solved the equation there for x. Now my last example is this one. 9 to the x plus 2 power equals 27 to the third power. Now this one has a couple of things going on. We have a more complicated exponent on this side, and notice that I've got to rewrite both sides again. Now I cannot use 9 because 27 is not a whole numbered power of 9. 9 to the first power is 9. 9 squared is 81, so I can't use 9. But I can use 3 because 9 is a power of 3, 3 squared, and 27 is also a whole numbered power of 3, in other words, 3 cubed. So what I'm going to do in this case, I'm going to write, in terms of 9, I'm going